Okay, I got some new goodies today. Here's the first set of directions. Determine whether the ordered pair is a solution to the linear inequality. Okay? Alright, so determine, that means yes or no, but we can't just guess. Okay? You have this inequality. It says y greater than or equal to negative 2/5 x plus 3, and then that's a semicolon. And then you have a coordinate with 0, 0. Now, of course, that means x, y. So how this is going to work is 0 is going to go in for y, and 0 is going to go in for x. All the variables are going to be eliminated. So you line up your symbol. You have 0 on that side. And you have negative 2/5 times, and you want to put the 0 probably in, or you can put it in parentheses or not, and then plus 4. Now this side's already set. This side's not, so we have to times first. 0 times anything is 0. Then plus 4 is 4. Now, does that eat the bigger number? Well, 4 is bigger, and it's not. Okay, so that's a no. Okay, next one. And that's pretty much what you're doing here. Okay, so 1 goes in for y, and negative 6 goes in for x. So we have 1 greater than 5 times negative 6 minus 12. If you want to make that plus negative 12, be my guess. Oh, sorry, I forgot the 3. 3 times 1. So neither side's set, so we times over here, we have 3. Then we times over here, 5 times negative 6 is negative 30. Now this side right here is set, that has 3. And over here we have to then add negative 30 and negative 12. And that would be negative 42. So after you've replaced them, you want to times. And a positive is always bigger than a negative. Okay, that's always got a more higher value, and it eats a higher value, so that is a yes. Okay, next one, y greater than x minus 3. Okay, so if you want to write the minus as a plus negative, that's fine. You don't have any multiplication. So y we're going to replace with negative 7, and then x we're going to replace with negative 3. So this side is set, it's negative 7. And over here we have negative 3 plus negative 3. Okay, there's no times, so we need to do the operation from that side. Negative 3 plus negative 3 is negative 6. Now each side is set. We know the value on each side. Okay, when I have two negatives, the smaller negative always has the higher value. Does it eat negative 6? No, it does not. So that is a no. Okay, then the last one. Y is less than or equal to 2/3 x plus 4. Y is less than or equal to 2/3 x plus 4. Okay, so 3/6 is a number we are testing out. Okay, so 6 will replace the y, and then 3 will replace the x. Remember, that's times right there. 2/3 times x. So this side is set. We know the value on that side, 6. We don't know the value on this side. We have 2/3 times 3 plus 4. So we need to times first, 2/3 times 3. That's 2, and then 2 plus 4 is 6. Okay, now there isn't a higher value. It's the same exact number. So if the line is there, which it is, then it's a yes, that is a solution. Okay. So that's what you're doing. You're just putting those numbers in for both x and y. Remember, if a side's set, if it's not set and there's a bunch of crap over there, you want to times first, then add, if there is times. See, this one didn't even have times. It was just negative 3 plus negative 3. That side was set at negative 7. But the other side, we got to take negative 3 plus negative 3. It's negative 6. Okay, now the next part is kind of a setup for tomorrow. All you're doing is rewriting the equation in slope-intercept form. Now, we've done this before, but it's never had an inequality in it, okay? So rewrite in slope-intercept form. Okay, rewrite in slope-intercept form. Okay, it says negative 3x plus y greater than or equal to 5. Now, remember what you want to do. You want to get the y by itself. You can put a 1 in front of it if you want, or you can just leave it as y. But it's positive, so we don't have to switch. So don't switch. Remember, switch, you don't want that to be a negative y term. Okay, so we add 3x. Then we make a 0x, and we add 3x there. Okay. So I line up my symbol. You get 1 times y. 0 plus 3 is 3, and then plus 5. Now, then you can divide everything by 1. Obviously, you're not going to have decimals, so we have y greater than or equal to 3x plus 5. Okay? And that's the m, that's your b. You don't need to put m and b if you don't want. You don't have to graph it. But now y is by itself. Now, you're like, why are we doing this again? It seems like the same thing. Well, this one's going to be the difference, okay? Okay, your y is a negative, okay? So, oh yeah, by the way, this said 6x minus y greater than 5. The original problem said 6x minus y greater than 5. So minus y is a plus negative 1y, okay? And that's what that's in there right now, plus negative 1. You have to switch, because you don't want that to be negative. So, but there's one thing you have to watch now. Opposite of 6 is negative 6. Opposite of negative 1 is positive 1. And you need to flip the sign, okay? The opposite of 5 is negative 5. Because when we're changing the sign switches. That's one thing you got to watch out for. So plus 6x. Then I make a 0x, so I have a place to add 6x. Okay, so I've got 1 times y on this side. The other side I drop my x, 0 plus 6 is 6, and then plus negative 5. Okay, now divide by your 1. You got y, 6 divided by 1, 6x. Plus negative 5. And now mission accomplished. Okay, we have the y by itself. If you want to put mb, you can. You don't need to. Okay, next problem. X minus 4y less than 20. X minus 4y less than 20. Can you see it? Okay, so we have to get the y variable by itself. And it's a negative, so we have to switch. So opposite of 1 is negative 1. Opposite of negative 4 is positive 4. Opposite of less than is greater than. Opposite of 20 is negative. See, before when there was an equals, equal doesn't have an opposite, but greater than and less than signs do. Okay? So plus 1x, make a 0x, and add 1x to that. So 4 times y. 1x plus negative 20, okay? Then divide everything by your 4. Okay, 1 divided by 4 is a decimal, okay? So we keep it 1 over 4. It's not 4, okay? 4 divided by 4 on top and 1 on bottom is 4. 1 divided by 4 is a decimal, plus negative 5. And now I'm good to go. Okay? Now, next one, get that y by itself. You can put a 1 in front of it, or you can just circle the y. It doesn't really matter, okay? But we don't switch, okay? We don't switch because the y is positive regardless. Okay, so add 3x. Then I make a 0x, so I have a place to add 3x. So we line up the symbol, 1 times y. So 0 plus 3 is 3, and then plus 6. Now, divide by 1. 3 divided by 1 is 3x plus 6. Okay, that's the answer. Okay, now you'll need some graph paper on the last part. Okay, so again, I'm throwing three different things at you. First, you're putting numbers in for X and Y, figuring out each side with order of operations, and then determine yes or no. The second part, we're just getting the Y by itself, but remember, when you have to switch, you also have to switch the inequality. Now, here's the graphing part. You need to represent, so on this first part, what we were doing, we were just determining if that was a solution, yes or no. Now, on the yeses, that's not the only solution, okay? There's an infinite amount of solutions. What we're doing on the next part is representing all solutions, and the only way to do that is on a coordinate plane graph. So we graph the line just like we do with the equals. You make sure the y is by itself, and it is, okay? And one thing, if you have the line underneath, you just are going to put regular line, okay? You'll see why I wrote that here in a bit, but put that regular line. So that means I start off just graphing a regular line. The y is by itself, so we have our m and b. So the slope -2, that has to have a 1 over it, and then under it, and then +5. Your slope has to have a 1. Okay, so the y-ant positive's this way, so 1, 2, 3, 4, 5. Then forward 1, down 2, it's rise over run, so the rise is negative, and then forward 1, forward 1. Then you take a straight edge or ruler and make a regular line. Now, the reason you made a regular line, you have the equals. Every point on this line, every x, y point, makes the y equal to -2 times the x plus 5. Okay, so we have the equals part graphed. Now, how do you graph the less than part? Well, here's what you're going to do. You're going to write test. You're going to pick a coordinate and put it in for y and x. Now, what coordinate do you pick? It doesn't matter as long as it's not on the line, okay? Just pick the one I pick in the video, but on your own, okay, it doesn't matter. If you can get in that coordinate, it might be somewhere here, it might be better, because these are both positive. X is positive, Y is positive, then you don't have to worry about negatives. So I'll go 1, 2, 3, 4 forward, and 1, 2, 3 up. Now you got to label that right, okay? You're going to put X, Y. Now the 4 is the X, and the vertical, the up, down, 3 is the Y. Okay, I like to pick a point in there, then I don't have to worry about negatives. Okay, so what we're going to do is, instead of putting Y, we'll just write it, copy it down. And 3 is going to go in for Y, and then 4 is going to go in for X. So we have 3, and you're going to have -2 times 4 plus 5. Now this side's already set at 3. Now to find the other side, you got to times to get -8, and then you add 5, and that's -3. Okay, this is bigger. Is it eating that number? No. Okay, so over that point you put no. So on this side of the line, every point I would pick over here is a no. Every point I pick over here is a yes. And you're supposed to highlight the yes sign. This isn't me crossing it out. This is me highlighting it. You're supposed to highlight. Don't waste a bunch of time doing it, but that's what you do. So that means every point over here you could plug in for X and Y, and you'd end up with a yes. The line itself is where they're equal, the points on the line. Okay, next one. MB. The Y is by itself here. So slope, y-ant. So the slope's 2 over 1 minus 1's the y-intercept. Now, oh shoot. You know how I wrote regular line up here? Now there's not that equals to line. So it's not going to be a regular line, it's going to be a dashed line. Okay? You're like, what do you mean by that? Well, you'll see here in a bit. So -1, then I go forward 1, up 2. Now when you take your ruler, you don't make a solid line, you just make it dashed here. I put my ruler over it, but I go dash, 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 okay? Just like that. It's like dash. That means these are all the points that when you put them in for x and y make this side equal to this side, but it's not equal, it's only greater than. Now to find what side's yes, what side's no, again, I'm going to go 1, 2, 3, 4, 5 up 1, okay? So I'll put 5, 1, okay? So remember, 5's the x, 1's the y. You can't get that screwed up or you're not going to get it right, okay? So I just write what I have. I don't put MB anymore. I've got that. That's done what it needs to. So y is 1, and then 2 times x, but x is going to be replaced with the number 5. So we have 2 times 5 minus 1. So this side is set at 1. 2 times 5 is 10. 10 minus 1 is 9. Or plus negative 1, it's still 9. Now 9 holds a higher value, but it's not eating that. So that is a no once again. So where that points out, I put no. So on the other side of the line, that line separates the no's from the yes, the line I just drew. So yes is over here, so you highlight the yes. Okay, now we got an interesting one here. I don't use slope because x isn't even here, so x not here. So that means you're going to go 1, 2, and 3. And also it's going to be a regular line. So you remember those. X isn't here, so you make 3 coordinate points. The letter that is there, negative 2, that means all the y's are negative 2's. Every one of them, okay? That says x, y. Sorry, I'm not good at drawing y's. Then the one that's not there, we'll just pick 1, 2, 3 because it's easy. Okay, so 1, negative 2, x, 1 is this way, and then on y, negative 2 is this way. Okay, 2, negative 2, 2, negative 2, 3, negative 2. So it's a regular line, so then pick a point somewhere. Usually I pick it in this quadrant here. And I'll go 1, 2, 3, 4. So x can be 4, y 1, 2, 3. Okay, 4, 3. Okay, so y less than or equal to negative 2. So the y is replaced with 3. This is higher value, that's a no. So I'm on a no streak, you can't overthink it. So no, over here is yes. You highlight the side of the line you drew, that is yes. Okay, next one. Y and x are both here again. The y is by itself, so we're going to use the MB, the slope intercept. So slope 3 over 1, the y-int negative 5. So the y negative's down here. So 1, 2, 3, 4, 5. Then forward 1, up 3. Okay, line needs to be dashed. It's a dashed line. So when I make my ruler, I make it dashed. Okay, now I need to pick a point. I'll go 1, 2, 3, 4, 5, 3. Okay, so 5, comma 3, x, y. You're forward 5, so x is 5, 3 is y. So write it down. Now take out, replace the y with 3, replace the x with 5. So 3 times 5 is what that is. It's not 35. 3 times 5 minus 5. So 3 times 5 is 15. 15 minus 5 is 10. If you want to make it plus negative, fine. Okay. Okay, 10's bigger number, and that's once again a no. Okay, I don't get no every time. It's just so it worked that way. Okay, so no, yes. It's not always that way. Okay. Okay, then the final problem. X less than or equal to negative 2. Okay, so actually hold on a second. Switch that problem. I'm switching it, okay? So y not here, so we're not going to use the slope. So if y is not here, I can put anything I want in for it. 1, 2, 3. Now I focus on the letter that is there, the x. So x is negative 2, okay? Okay, given the fact that y isn't here, I can be whatever I want, okay? So, negative, remember, x, y. Negative 2 on x is backwards 2, 1 on y is up 1. Back to the middle. Negative 2, up 2. Negative 2, up 3. Okay, so it's a regular line because the line's there. That line, that little line determines whether it's regular or dashed. Okay, then pick a point somewhere. I'm going to go 2 and 2. Okay, so x greater than or equal to negative 2. Okay, so all we need to do is put 2 in for x. Y isn't here, so it doesn't really matter. And finally, this is my higher value, and it eats the higher value. Finally, I get a yes. So this side's the yes, this side's the no. Okay, so I highlight the yes.